Assalamualaikum warahmatullahi wabarakatuh. Hello students, today we are going to talk about physical quantities. Before we start, you must know some vocabularies in physical quantities.
And we must know some vocabularies. It is very important. We have quantity in bahasa Besaran, base, pokok atau utama, derive, turunan. So, when I say base quantity, it means besaran pokok. And when I say derived quantity, it means besaran turunan. And then we have unit, satuan, magnitude, similar with value, nilai, equation or formula, similar in bahasa persamaan atau rumus, Scalar, besaran fisika yang hanya mempunyai nilai, and vector, besaran fisika yang mempunyai nilai dan arah.
The topic is physical quantities. So, what is the definition of physical quantities? Physical quantities are all quantities that can be measured and consist of a magnitude and a unit. Remember, consists of a magnitude and a unit. For example, car move with velocity 10 meters per second toward S. A car moves with velocity 10 meters per second toward S. So, which one a physical quantity? It is quantity and consists of magnitude. 10 is magnitude, unit, meter per second is unit. Now I will show you another example of physical quantities. I'm measuring the length of the box with a ruler, and I got the length of the box is 26 centimeters. So now we have physical quantities is length of the box, and 26 is magnitude, centimeter is unit. Physical quantities. Physical quantities are classified into two types: base quantities and derived quantities. A base quantity is a basic of physical quantity. And a derived quantity is a quantity that is divided from base quantity. I will give you a parable of both. There is the building of a house. Okay. Derived quantities is like the house that was built up from a collection of bricks. And how about base quantities? Base quantities is like the brick. Okay, the basic of building block of a house.
Now we talk about physical units. There are some concepts of units in physics. A unit has to have a special name and symbol. A unit of measurement is a definite magnitude of a quantity, defined and adopted by convention or by law, that is used as a standard for measurement of the same kind of quantity. So remember, unit has name, symbol, and standard. And we have many units based on international system of units. Units of base quantities and units of derived quantities. For example, unit of length is meter, mass is kilogram, time is second. Unit of area is square meter. For example, standard kilogram, we have platinum iridium cylinder. And the other example, we have Kelvin and ampere. Now we want to know how to get a unit of derived quantity. We know that a derived quantity is a quantity that is divided from base quantity. For example, unit of area, velocity, and density. Area. Defining equation of area equal length times width. So unit of area is square meter. Why? Because unit of length is meter and unit of width is meter. So meter times meter equal square meter. Velocity. We have a formula of velocity is distance divided of time. So units of velocity is meter per second. Why? Because unit of distance is meter, unit of time is second. How about density? Defining equation of density equal mass divided of volume. So we have units of density is kilogram per cube meter. For example, distance. Distance in real life similar with length. So distance is base. How about the others? Now we have key concepts. First, a physical quantity is a quantity that can be measured and consists of a numerical magnitude and a unit. Second, the physical quantities can be classified into base quantities and derived quantities. Third, there are 7 base quantities: length, mass, time, electric current, temperature, amount of a substance, and luminous intensity. 4. There are some derived quantities, for example, area, volume, force, energy, etc. And the last one, we have many units based on international standard of units. Now we talk about scalar and vector quantities. Scalar quantities are quantities that have magnitude only and is completely described by a certain number with appropriate units. Remember, scalar quantities has magnitude only. For example, the distance of point A to point B is 7 meters. Okay. The other examples: measuring mass. For example, mass of object is 30 grams, and then measuring temperature is 2 degrees Celsius. How about vector quantities? Vector quantities are quantities that have both magnitude and direction. Remember, scalar quantities have magnitude only, and then vector quantities have magnitude and direction. For example, when we talk about force, we need magnitude and direction. Analyze example of scalar and vectors. You think some quantities is scalar or vector. Okay, thank you. I hope you will get many information from my video. Thank you very much.